Today I would like to present our chosen compound, which is ethanol anhydride, also known as acetic anhydride. It belongs to carboxylic acid derivative, specifically the acid anhydride functional groups. This is the chemical structure of ethanol anhydride. Its molecular formula is CH3CO2O. As you can see, the structure consists of two carbonyl groups, C double bond O, connected by one oxygen atom. This arrangement is the characteristic structure of all acid anhydrides. Acid anhydrides can be divided into two types. The first one is symmetrical anhydrides, and the second one is mixed anhydrides. A symmetrical acid anhydride contains two identical acid groups, while a mixed acid anhydride contains two different acid groups. Ethanol anhydride is classified as a symmetrical acid anhydride because it contains two identical acetic groups, which is CH3CO, joined by one oxygen atom. In addition, acid anhydride are formed through a condensation reaction between two carboxylic acid molecules, where one molecule of water is removed. In this case, ethanol anhydride is formed from two molecules of ethanoic acid. That's the end for the introduction part. Let's move to the next one.
Chemical properties of ethanol anhydride make it suitable for manufacturing anti-inflammatory drugs such as aspirin. Firstly, it acts as a strong acetylating agent. Ethanol anhydride readily transfers an acetyl group to other molecules. In aspirin production, it acetylates the hydroxyl group of salicylic acid to form aspirin, a widely used anti-inflammatory drug. The second chemical property is it is a highly reactive electrophile. The carbonyl group atoms in ethanol anhydride is strongly electrophilic, making them susceptible to nucleophilic attack by functional groups such as alcohols and phenols. This allows the acetylation reaction with salicylic acid to proceed efficiently under relatively mild conditions. The third chemical property is that it can form a useful leaving group. During the reaction, one acetic group acts as a good leaving group, facilitating the transfer of the acetyl group to the drug precursor molecule. Lastly, producing ethanoic acid as the byproduct. The reaction generates ethanoic acid rather than water, helping to drive the reaction toward aspirin formation and improving yield.
The first reaction is esterification. When ethanol anhydride reacts with an alcohol like ethanol, the anhydride bond breaks. This reaction produces an ester called ethyl ethanoid, which is commonly used as a solvent in industry, especially for glues and nail polish remover. It also forms ethanoic acid as a byproduct. As shown on the slide, here is the balanced chemical equation for this reaction. The second reaction is amide formation or amidination. In this process, ethanol anhydride reacts with ammonia. Ammonia acts as a strong nucleophile and attacks the electrophilic carbonyl carbon. This reaction yields a primary amide known as ethanamide, which is an important intermediate in the chemical industry, and also again, ethanoic acid is released as the byproduct. This is chemical equation for the synthesis.
In comprehensive summary, ethanoic anhydride functions as indispensable for dimension component within modern industrial chemistry, driving critical operation within the pharmaceutical sector for the large-scale synthesis of essential medications such as aspirin.
The primary commercial and chemical advantage of this compound stem directly from its structural classification as an acid anhydride, a configuration that yields the optimal level of chemical reactivity required for the synthesis. This unique molecular trait enables the acylation to proceed with the exceptional efficiency while completely avoiding the generation water, which is H2O, as a wanted byproduct. By preventing water formation, the process eliminates the risk of site of reaction for hydrolysis, thereby significantly simplifying the purification of the final therapeutic product. Ultimately, the ranges of understanding of the distinct chemical properties as mechanic behavior of ethanoic anhydride underscore fundamental principle in organic chemistry, that structural variation within the carboxylic acid derivative directly dictate limit and govern their practical utility, overall availability in industrial application. Okay guys, that's all from our group. Bye.